the right-hand side. Here we need to place the, we will place the method here by the identity here. So we will be have here, if A is 3 by 3, then we will be having another 3 by 3. So we will be having 3 rows and 6 columns here. Okay. Now here we will use the elementary row operations to get this into the following form. So here we need to get the identity to the left, and what we get to the right is the inverse of the matrix. Okay? So reduce here until you get the identity here to the left, and this is the so-called Gauss method for evaluating the, we will do an example in short, but before you do that, you need to check, okay, if determinant of A is not equal to 0. So this condition here, determinant of the coefficients matrix not equal to 0, it's very crucial in linear algebra and in matrices, because it means if it's equal to 0, that the determinant equals to 0, the system has no solution, and there's no inverse of the matrix. It doesn't exist. So it's always good to check whether it's equal to 0 or not. If it's equal to 0, you leave it there. You don't need to proceed. If it's not, then you just proceed. Now this step here, I will just try to simplify it here for you. If we are talking about 3 by 3, so let's assume here A is the matrix that has A, B, C, D, E, F, G, H, I. Let's say this is the 3 by 3 matrix. Sorry, the 3 by 3 matrix. I want to evaluate the inverse for. Now I will put next to it the identity. Now here, notice that I choose this identity depending on the dimension of the original matrix. This is 3 by 3, so I need 3 by 3 identity. And this is A, and this is here I. So this is exactly this one. Okay. Now here, what I need to do, I need to transfer this into this form, which is here I will be having 1 0 0 0 1 0 0 0 1, and here to the right I will be having anything here to the right. So I will be having a 3 by 3 matrix with, let me just put here asterisk to mean it's variable, it's anything. Okay. And this is here obviously the identity. So I managed to get it in this form, the identity. And this one here is going to be the A inverse. I hope the method, and here of course the elementary row operations are applied to get there. I admit it's not a very simple method, especially if you have many, let's say, so large dimensions, 4, 5, but it is actually the way, or the algorithm behind any software that evaluates the inverse of a matrix. Of course, nowadays there are many online platforms that they have the abilities to evaluate the inverse of a matrix. It is based on this reduction. So starting by putting this to the left here, the matrix, to the right, the corresponding identity, and then thinking, how can I use the row operations to get the identity to the left, and whatever I get to the right is the inverse. Any questions so far? No one is asking questions.
I have a question, sir.
Yes, please go ahead.
Is the Gauss and the Gauss-Jordan methods the same?
Sorry?
Is the Gauss-Jordan method and the Gauss the same?
Yes, this is the Gauss and the Gauss elimination method.
Okay.
But the difference is in the previous, did you attend this morning the tutorial?
No.
No, okay. When you are solving the linear system only, you put A and next to it one column, which is the right-hand side. But to evaluate the matrix, you put here a 3 by 3 matrix next to it, the 3 by 3 identity. So elementary row operations is just the Gauss method.
Okay. Yeah.
Okay?
Yeah.
So let me solve an example here with you, and you will see how this method works. Let's do an example. No questions. Okay, great. So let me just put this matrix here. So example, how to solve. Of course, there is a shortcut. I will try to find out. I have it somewhere. It's just a little bit more complicated than 2 by 2. Evaluate the inverse, A inverse for A is equal to, so 302. So here I have some zeros so that don't have many steps. 2, 0, negative 2, 0, 1, 1. Okay. Now the first step here, evaluate determinant of A is not equal to 0. So I just assume that you know how to evaluate this determinant. It's actually straightforward. So here 3 times 2 minus 0, so 6. And here you have 0, of course. Here you have 2 times 2, 4. Right? So is it 10? 3 times 2, 6 plus 2 times 1, 4. Okay. So I just evaluated it. I think it's 10. It's not equal to 0. Okay. Then the next step, what we do, so I try just to make, we construct the augmented matrix. So that means you put this matrix, you are evaluating you are going to evaluate its inverse, and here you just add to this. So this is just a line that is separating to show you that this part you need to make the identity. It's one matrix with, as I mentioned, so this is 3 by 3. This one is 3 by 6. So 1, 2, 3, 4, 4, 5, 6 columns. Okay. Now I will work on this matrix here. Now, very important here, you need to work systematically. So that means here you need to, in each step, you need to find out what am I doing next, or not to find out, you need to determine what am I doing next. Okay. So for instance, if I want to get rid of this 0 here, of this 2 here, for instance, okay, this 2, I will be adding, you see here, I have negative 2 if I add it, so I will add this one. Okay, so 2 plus 3. Then, okay. So I will be adding, so as we agreed before, the steps here, I will be replacing row 1 with adding row 1 plus row 2. Just add these two rows because here you have 2 and -2. And again, I will urge you to do it on sheet, even though it's a very simple step. But just do it on scratch paper somewhere. So here I have 3, 0, 2, 1, 0, 0, 2, 0, -2, 0, 1, 0. Okay. So here 3 plus 2 is 5, 0, 2 minus 2 is 0, 1, 1, 0. Okay. Agree? So even it's a very simple step, just use the scratch paper. So here I have 5, 0, 0, and here I have 1, 1, 0. The other lines remain untouched here. So 2, 0, -2, 0, 1, 0, 0, 1, 1, 0, 0, 1. Okay. Now the next step, because I don't like this, I will just maybe
Why,
you
Professor?
yes, yes,
Why is it 110 now?
yeah, because you just add the two rows. Yeah, I added the first two rows to each other. So you add, don't forget the right hand side also to consider it in this step.
Okay.
Okay, 1 plus 0 is 1, 0 plus 1 is 1. Okay. So that's why you can easily do simple mistakes here. That's why it's very much advisable to do it not in your head, just on a scratch paper. You are on the safe side. Okay, you got it? Okay, now
Yes.
here I'm going to just get rid of this 5 by dividing by 1/5 R1. Of course, here I'm going to get some fractions, but no worries. I just focus on this one to get it 1. All right, so I have 1, 0, 0. So here just 5/1 is 5 is 1. Here I have 1/5, which is 0.2. Here 0.2. Here 0. And then here I have the same. Sorry, I'm sorry, it's switching off all the time. So meanwhile, I will be just writing the two rows that are not changed there. And then here I have 0, 1, 0. I need to zoom it out a little bit. Okay, see what you see here. Okay, so a little bit more zoom. Okay. Okay, so second row and third row unchanged. Here 0, 1, 1, 0, 0, 1. Okay. So this, don't worry about this. 0.2 is just 1/5. 1/5. All right. Now then the next step, don't forget, this is something you can easily lose track. Okay. So the next step is I'm going to get rid of this 2 here. Okay. This 2. Okay. Now, as you see here, I have R1, R2 is equal to 2 R1 minus R2. So let me try to check it here. So 2R1 is 1, 0, 0, 0.4, 0.40. And here down I have 2 here, of course. Negative 2, 0, 2, 0, negative 1, 0. So what I got here, 0, 0, 2. Okay, so 0, 0, 2. Here I got negative 0.6. Sorry, 0.4 and 0.6. Actually, was it negative 2 or 2? Okay, so what I did here is negative 2R1 plus R2. Okay, negative 2R1 plus R2. So let's see what we get. Negative 2R1. I get here negative 2, 0, 0, negative 2 times 2, 0.2 is 0.4, negative 0.4 and 0. So this is 2, negative 2R1, if you like, okay? Now here, I added 2R2, so I have here 2, 0, negative 2, 0, 1, 0. So here, of course, this will cancel. I end up of having 0, 0, negative 2, 4, negative, sorry, 0.4, and here 1 minus, it's 0.6 positive and 0. Okay, I hope you're okay with this calculation. So let me just write it here. So this is the second row. So the first one is not changed. And 0.2. Notice that with this operation, just like we did before, you have, it's very sensitive. You need to just in each step ask yourself which row I am changing. And sometimes you are working on other rows, but they are not changed. Like here, we use row 1, but it's not changed. We are changing row number 2 because we are eliminating this. So here I have 0, 0, negative 2. Then I got here negative 0.4, 0.6, and 0. And here down 0, 1, 1, 0, 0, 1. Okay, you see, systematically, I am working here on each step to get rid of one element. Now here, obviously, we have two steps. Here, for instance, if I just multiply this one, R2, just this step, you shouldn't do it actually, but I like to work with ones, because at the end of the day here to the left, I try to make it 1. And if you are adding, subtracting, multiplying, if you have 1 here, it's better than working with 7, 8, 9, whatever. So you can keep it and work with it, but I just like to reduce it to 1 because I have in mind that here to the left, I will be getting the identity. So I will see how to get it. So here it's not changed, 0.2, 0.2, 0. And here, since I divided by 1, negative 1 here, 1/2. So I will be getting here, of course, 1. Here I will be getting 0.2 positive. And here I get negative 0.3 plus 6 divided by negative 2. And here, of course, it remains 0. Here I get 1, 1, 0, 0, and 1. Okay. Now you see here, there is a nice line here, but it's in the wrong place, this line. Okay. So I have here in mind, so it's just like you are doing something and you know your final, let's say, destination, how ultimately this side will be looking like. And this, if you have this in mind, you will say, well, I have it here and this should be in the third position. So here you can just swap these row 2 and row 3. Okay, just swap them. And if you do this, you need just to do it for the entire row. So here the whole row will be replaced in the second and the third positions. Okay, we just I did this because I have in mind the identity at the end here to the left. Okay, so what I will be getting is, okay, so 1 0 0, just push it down a little bit. So 1 0 0, then I have here 0 0.2, 0 0.2 and 0. And then here I have the second line. Now I have 0 1 1 to the left, and then I have 0 0 1, and now the last position I have 0 0 1, and here I take the values from the second to the third row, and I'm almost done actually. Only I need to eliminate this number here, and obviously this is easily done by subtracting this minus this. Okay, okay, so I will be subtracting R2 minus R3. So R2 minus R3, here I will be having the nice matrix, the identity to the left here, 0 0.2, 0 0.2, 0. Then here I will leave this out. I will do it on scratch paper on the side, 0 0.2, negative 0 0.3, and 0. This one. Okay, now the second row we said we subtract R2 minus R1. 0 minus 0, 0. 1 minus 0 is 1. 1 minus 1 is 0. This is what we wanted actually. 0 minus 0 0.2 is minus 0 0.2. And 0 minus minus 0 0.3 is positive 0 0.3. And 0 minus 1 is 1 minus 0 is 1. Okay. Okay, we are done actually. So this is the final answer here. This is I. So I managed to get I here to the left. That means here whatever I have is the inverse of the matrix I'm looking for. So here the conclusion is that A inverse is equal to the 3 by 3 matrix as expected, 0 0.2, 0 0.2, 0, negative 0 0.2, 0 0.3, 1, 0 0.2, negative 0 0.3, and 0. And now check. What does it mean, check? It means here you go to the original matrix and multiply it either from the right or from the left with this one. and you will be getting the let's say A multiplied with A inverse, you will be getting the identity matrix, which is 1 0 0 0 1 0 0 0 1. So please check that. It's a good exercise where you just have to just practice multiplication, actually. Just practice multiplication. And okay, so to summarize this, this method actually it works also for 4x4 and 5x5, 4x4, 5x5 matrices, etc. So this method will work. Of course, there you need to just use the corresponding identity and try to solve it. It's a very tedious procedure actually when it comes to 4x4 and 5x5, but it will work. It will work. This method works for all, even for a 2x2 it will work, but we have just a shortcut there. We can prove it actually for a 2x2 using this method. Okay, now before we go to the final example for today, any questions? Do you have any questions? Why did we did 1 and 2? Well, why did we add 1 and 2? You mean this last? Someone was asking, Abu Zafar, which step you are asking? The first one? There was a question by a guy who's not there anymore. But anyway, the answer is that you see this circled element is just like if you go to a linear system, why you multiply with the negative to get rid of it's after all it's called elimination method. That means what number I have to multiply, what operation I need to perform, addition, subtraction, to get rid of that. So for instance, here I just subtracted these two because 1 minus 1 will give me 0, which is my goal here. Okay, so each step you need to bear in mind, I'm going to eliminate this element. What do I need to, which rows I need to use? What do I need to multiply? Which operation I use, addition or subtraction? Okay, so no questions. So let's move to our final example for today. Now, to wrap these things up here, what is the or how we use this theory here that we learned today to solve a linear system? Okay, so here let's summarize. Solving a linear system using the inverse, of course, if it exists. Now, we are given the system in let's say matrix form, coefficients matrix times this is matrix multiplication. So we are given the coefficients matrix. The right hand side is the column B, and the capital X is the unknowns. If you are given the equations, well, you can just find out the matrix. The first step you need to do is to write it in this form. Then A inverse, does it exist? And this is, of course, determinant of A. Is it equal to 0? Okay. If it's not equal to 0, then we find the determinant, sorry, the inverse, then A inverse A, we multiply everything with A inverse from the left. Now here you have to be careful, multiplication from the right to the left. This will give me I times X is equal to A inverse times B. So all you need to do after you find the inverse to multiply it with the right-hand side of your equation, and you are there. This is the solution. Let's see an example. Okay, I have here a 3 by 3 matrix, 3 by 3 system, and it says the following. I'm not going to evaluate the where is it? I have it here somewhere. Just 1 second. Okay, so this is the example. X solve, of course, using this system, using A inverse X plus Y plus Z is equal to 6. The second equation has no X, is 2Y plus 5Z equals to -4. And here last one, 2X plus 5Y minus Z is equal to 27. So this is my linear system using, I'm going to solve using A inverse method. Okay. Now here, if the question indicates, I keep getting this question very often. Can I use any method to solve the linear system? If it's not indicated, you can use any method. You are free to use any method. But if the question is asking you to use a specific method, of course, you have to stick to that. Okay, so first step, we will write it in this form. So I hope that everyone knows how to do this. So this form, it says AX equals to B. Now A, what is A? A is the coefficients matrix. Here by default, I don't have coefficient. It means 1, 1. This is 2. This is 5. This is 2. This is 5. And this is -1. Okay, so this is 1, 1, 1, 0. Because we don't have here maybe I have to write 0. We don't have an X here, so it's by default 0X. And 2 and 5 here. And here you have 2, 5, minus 1. Here the coefficients, the variables matrix is just these variables, X, Y, and Z. So this is my capital X, if you like. So this is small x, small y, small z. It's the variables in one column. And here to the right, it's these values that we call just capital B. So okay, so this, we will keep it to the end after we evaluate the inverse here. You see, we have it here. So this is B. So after we evaluate the inverse, we will need this to evaluate the solution. Now here, what I'm going to do is the following. I'm going to give you a shortcut. By the way, if you carry the matrix multiplication of this system in matrix form, you will be getting the same equations you got at the beginning. Now here, I have A. I'm not going to evaluate it. Of course, you can evaluate it using, I don't know, which method, but okay, so here 1, 1, 1, 0, 2, 5, 2, 5, minus 1. Inverse, the inverse of this one is equal to 1 over, I think the determinant is minus 21, and here there's a formula for 3 by 3 matrix that's used here. So don't worry about this formula. It's just evaluated this way. So this is the inverse here, -3 and 2. Okay, so this is the inverse. This is A inverse. Now the solution of the linear system is the XYZ, which is my capital X here, is equal to A inverse multiplied by B. Now we know A inverse, this is equal to -1 over 21 multiplied by -2763, 10, -3, -5, -4, -3, and +2. Okay. Now here we need to multiply this with the right-hand side. Remember what was the right-hand side here? Let me check it. 4, -6, -4, and negative or positive 27. Now we need to carry out this. You can just multiply this out and then multiply it with this, and then you get the solution. You just multiply it out and you get the solution. So I just multiplied this out, and this is -1 over 21. So here I have, remember, I have this one has 3 columns, this one has 3 rows, so it will work. -27 times 6, 6 times -4, 3 times 27. So I evaluated this as -105. Here I have 3 times 3 times 3 times 1. So I have 3 rows, 1 column. And this one here, just multiply this 10 times 6 minus 3 times 4 and so on. So I got here -63, and here 42. If I multiply this out with this constant here, -1 over 21, I got 5, 3, and -2. And remember, this is here, always just think about it. This is the set of variables. So it's the solution, okay? So it's the solution. X equals, sorry, I need to switch it on again. We are almost done, actually. Okay, so this is the solution of my linear system. X equals 5, Y equals 3, Z equals -2. Okay, so X equals 5, Y equals 3, and Z equals -2 is my final solution of this. Okay, so as you see here, if I know the inverse matrix of the coefficients, multiply it with the right-hand side, I solved the linear system. Here, a warning before I end here. A warning, note A inverse is not equal to 1 over A. I saw, even though I keep warning the students, they think that in terms of numbers, this is not true here because you have another procedure. So it's not the reciprocal, yeah? So it means here, if you have inverse, don't think always it means 1 over the matrix. It's true for numbers, but for matrices, it has totally different meaning. It means here that the matrix that if I multiply with the matrix, the original matrix, I get the corresponding identity matrix for that. Okay. Okay, so let me see. All right, so okay, so dot product, yeah. Okay, so after you have this, you can just think about the system. You can recall the system of, if you multiply them out, just get the original system because of the definition of the matrix multiplication. Okay, so that's all for today. Next week we will be doing some a new method, which is Kramer's rule, which is basically using the determinants, another method for solving linear systems. Please try to practice solving, evaluating at least the determinants so that you will be able to use the method next week. And also make sure that you solve the worksheets that I'm uploading usually at the weekend, so that you get the benefit of that. Just practice and compare your answers before getting to the exam, so to avoid any problems. How did you get the 3 by 3 matrix above? You mean the inverse, right? Yeah, I told you there's a rule. The one with negative 727 and so on. Yeah, this matrix actually, you got it. I told you there is a rule for evaluating a 3 by 3 matrix, and it's using this rule. I don't have the rule now. You can Google it. I will try to find it out and then upload it to you. It's just here, it's not about how to get the inverse. This exercise or this particular example is just about demonstrating to you how, if I know the inverse of the coefficients matrix, how do I solve the system of linear equations? Simply, I need to multiply it with the right hand side. So this is what I want you to know here. Okay. How to do it, either using the previous step or the Gaussian elimination, or just, there's a rule, it's 1 over the determinant, but here you need to shuffle the coefficients. I will be uploading this to you if I find it. Okay. I had I got a new laptop here, so I don't have everything here. Need to look it up. But there is a rule. You can Google a rule for a 3 by 3 matrix. inverse. Okay. All right. So any questions? Okay, if you don't have any questions, we can leave it there. Remains to issue a nice afternoon and keep warm if you are in the snow. See you next week. Goodbye. And if you have any questions, you know how to get to reach me. And by the way, I uploaded the worksheet solutions and even the one that we did this morning. You may have a look at it and let me know if you have any feedback. And I'm going to upload the two sections that we did today. Have a look at it and then let me know if you need any assistance with that. Okay. So please try to learn and exercise because as we agreed, so now tomorrow, so next lecture will be in December. And as you know, we have holidays after the 22nd, I think, of December. And we're going to have the mock exam the last lecture. So I'm planning to do the mock exam at the same day. And then 2 hours, maybe we'll need 1.5 hours for the exam and maybe half an hour for preparation. And then immediately after the exam, just to have a look at the answers so that you have enough material to study during the holidays if you have time. And then, because after we get back, we don't have plenty of time until the final, okay? All right, thank you very much. Have a nice evening, afternoon. Goodbye.
Thank you, Professor.
You're welcome. Goodbye. Goodbye.
Goodbye.
Goodbye. Stay safe. Goodbye.